Welcome back, dear students. In today's lecture, we are going to learn about probability. So, probability of any event. Event is a thing that is going to happen that has certain possible outcomes of it. So, probability of any event is equal to favorable outcomes divided by total outcomes. So, what are the favorable outcomes? Favorable outcomes are the outcomes that are required as per the question. So, let's say if we are tossing a coin, so it can have head or tail. So probability of head will be an event, this will be 1 by 2, and probability of getting a tail will be 1 by 2. So probability is given as favorable outcomes over total outcomes. So the favorable is the required one is head or the required one is tail. Since there are two outcomes over there, so probability of getting head is 1 by 2 and probability of getting tail is again 1 by 2. Now there are some properties that are associated with probability. Let's get onto them. So what is the probability? First of all, it says probability of occurring of an event plus probability of not occurring of that event sums up to be 1. So let's say if two coins are tossed, so then you can have the possible outcomes as HH, HT, TH and TT. So head can come on the first one or head on the second one, head on the first one, tail on the second one, tail on the first one, head on the second one, or tail on the first one and tail on the second one. So it says probability of getting two heads was the event. So probability of getting a two head is 1 divided by 4. And probability of not getting heads, probability of not two heads should be 3 by 4. Now is it equal to 1? Yes, this will be 1, which is equal to 1, as it will be, we'll take the LCM, this will be 4, this cancels out, and my RHS is equal to LHS. So it is proved that probability of an event and probability of not an event is given as 1. So the total of the events is also 1. So it says probability of any event lies between 1 and 0. It can never exceed 1, it can never be less than 0. Now let's say if I ask you the probability of getting 3 heads when 2 coins were tossed. So I cannot have 3 heads in this case because the total outcome has only 2 coins with me. So this will become 0. So probability of getting 3 heads becomes 0. So I will call such an event as impossible event. Right? Such an event will be known as impossible event. But if I ask you that either of the head or tail will definitely come up, so I'll say that the probability is 1. Right? Then the probability is 1. So that is the sure event or certain event. Sure event or certain event. So probability of a sure event or a certain event will be 1. So probability of all the events should lie between 0 and 1. Yes, as we were discussing the cases, so the first case is tossing of a coin. Now since we know coin has two faces, so the total number of events will be 2 raised to the power n. Because since the number of faces is 2, so hence there is number 2, and n will represent either the number of coins tossed, or if one coin is tossed n times, 1 times, twice, 2 times, 3 times and 4 times. Since one coin is tossed, so this becomes 2 raised to power 1, so there can be only two outcomes, head or tail. First outcome is a head, second outcome is tail. If two coins are tossed together or one coin is tossed twice, this will be 2 raised to power 2, it means 4 should be the sample space, HH, HT, TH and TT. These will be the 4 cases. When 3 coins are tossed or one coin is tossed thrice, 2 raised to power 3 will become 8. So there should be 8 cases. So head, 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 tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, or all three of them being tails. Right? Now, if 4 coins are tossed together or one coin is tossed 4 times, so there will be 16. 2 raised to the power 4 will be 16 outcomes. So these are those 16 outcomes. So depending upon the sample space, you can answer various questions. Probability of getting 2 heads, so this will be 1 by 4. Probability of getting 2 tails, this will be 1 by 4. Probability of getting at least 1 head, so then this will be 3 by 4, and so on, right? Then in this case they can ask you probability that all of them are heads. All are heads, so this will be 1 by 8. Probability of all tails, this will be again 1 by 8. Probability of at least 2 heads, so at least 2 heads is 2 or more than 2, so this will count 4 by 8, right? In this case, let's say if they ask you about all heads, so this will be 1 by 16. All tails, this will be again 1 by 16. Let's say at least 3 heads, or this time let's take it at 3 tails. So at least 3 tails, it means again 3 or more than 3. This becomes 5 by 16. Then if they ask you at most 3 tails, so at most 3 tails means maximum can be 3, so you can take it as 3, 2, 1 or 0. So only this case will not be there, so this shall be 15 by 16. So for at most 3 you can have 15 by 16. So this is how you are going to find out the questions based on probability when they are asking about a question on coins. Now let's put it forward if they will ask you about dice. So once we are done with the cases of coins in which we saw that the number of total outcomes will be 2 raised to the power n, now let's come back to the dice. In this case, since dice has 6 faces, it's a cube, so 6 raised to the power n. So if one dice is rolled out, so 6 raised to the power 1, that will be 6. It can be number 1, number 2, number 3, number 4, number 5 and number 6. So probability of getting number 1 will be 1 by 6. Probability of getting number 2 is again 1 by 6. Probability of getting number 3 is 1 by 6. Probability of getting 4 is 1 by 6. Probability of getting 5 is 1 by 6. And probability of getting 6 is 1 by 6. You can also say if they ask about probability of number being an odd number, so 1, 3, 5, 3 by 6. Probability of a number being an even number, again 3 by 6. Probability that the number is prime, so 2, 3 and 5, again 3 by 6. So these are few of the possible cases for probability of a dice when one dice is being rolled up. So when 2 dices are rolled up, so the total event will be 6 raised per 2, that is 36. These are those 36 cases that if on the first die you get number 1, then on the second die you can also get 1, 2, 3, 4, 5 and 6. Or if on the first case you got number 2, so then on the second throw you can have any number from 1 to 6. Similarly, if you get 3 on the roll of a first dice, then you can have any number from 1 to 6 on the so on. Probability that the number is doublet. So what do you mean by doublet? Doublet means when both the dices have same number. So doublet of a number should be this. These all will be the cases in which you can see that the number is same on both the throws or both the trials. So this will be 6 by 36. Or they can ask you if the number being sum of numbers being 8. So now they want that if you add these numbers, one particular pair, so the sum should be 8. So we'll see 8, 8, 8, 8 and 8. So 1, 2, 3, 4 and 5 such cases. So this shall be 5 by 36. Now what if they asked you about probability of getting a sum which is equal or greater than 9. Now they want the sum to be 9 or greater than 9. Now to be 9, this will be the case 9, 9, 9, 9, or greater than this. These all will form the sum as 10, sum as 11 and sum as 12. So how many cases are there? 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So we will write it out. 10 divided by 36. Right. Now what if they ask you that probability that 3 comes on either of a dice. Right, that 3 should come. Either this would come on the first dice or this should come on the second dice. So you will see that in this particular column 3 is appearing on the second row and in this one 3 is appearing on the first row. So they will total make as 12 numbers, but this one is being counted in both the times. So then we'll subtract this one and we'll call it as 11 by 36. So there are 11 cases which will have 3 on either of the dice. Now if we ask you in which the 3 does not come either on the dice, so probability of not getting 3 on either of the dice. So either you can count them, this will be 25 by 36, or you can use that formula that probability of E plus probability of not E was 1, probability of E was 11 by 36 plus probability of not E is 1. So probability of not E is 1 minus 11 by 36. So probability of not E becomes 36 minus 11 by 36. This shall be 25 by 36. So you can directly either you count them or you put them in that formula that probability of E plus probability of not E is 1. If probability of getting 3 was 11 by 36, then probability of not getting a 3 will be 1 minus that becomes 25 by 36. So with this we have discussed about dice, 6 faces, 6 is for n, when 1 dice is rolled up or when 2 dice are rolled up. So once we have studied the probability of coins and we have also studied the probability of dice, the next case comes out to be cards. So we have 52 playing cards besides the joker, we don't count them. So 56 cards are further divided as they will be 26 red or 26 black. Then they are further divided as in red you can have 13 cards of hearts or 13 cards of diamonds, or you can have 13 cards of spades or 13 cards of clubs under the black section. So 52 cards, 26 will be red, 26 will be black. Out of them 13 of hearts, 13 of diamonds, 13 of spades and 13 of clubs. So I can tell you that there are 4 cards of a kind and 13 cards in total. This gives me the sum as 52. Let's write the total number of cards and with their numbers. So this is 3, 4 up to 10, and then it's jack, and then it's queen, and then it's king. Right. If he asks you that probability of getting an ace, so this is an ace, so 4 by 52, because these are again 13 cards and each of the card will be 4 of a kind. So probability of getting an ace will be 4 by 52. Probability of getting a number 3, so again 4 by 52. But if he asks you probability of getting 5 of spades, so there will be only one card, that is 5 of spades. Probability that it is a black card, so this will be 26 by 52. Probability that it is a red king. So first of all, the total number of king will be 4. Out of those 4 kings, they will have 2 red and 2 black. So the answer shall be 2 by 52. Right. So these are the few cases that they can discuss. Then probability, if they ever ask you probability of a face card, So these are known as face cards, as the card resembles a face. So hence 3 categories, 4 of a kind, 12 by 52 will be the possible cases for cards. So these are some important questions in which the total sample space or the total number of outcomes are always fixed. You can always write them. Then the question that they are going to put up will depend, and the answer will follow as per the question. So once we have discussed the probability of coins, dice and cards, so here is another set in which you cannot make a sample space, but definitely you have a fixed answer with these questions. So the question is, find the probability of getting 53 Fridays in a normal year. So how we are going to solve it? Now, first of all, we'll see that in a normal year, the total number of days that we have is 365 and 7 days constitute a week. So first of all, we'll find the total number of complete weeks and then we'll see. Now if I divide 365 by 7, this results into 52 complete weeks and 1 day is remaining, right? So this 1 day can be Monday, Tuesday, Wednesday, Thursday, Friday, Saturday or Sunday. So probability of getting this day being Friday will be 1 by 7. But not only this is amazing, but you'll see that if I replace it by any day, Monday, Tuesday, Wednesday, Thursday, the answer will remain the same. That is, probability of getting it to be Monday will be 1 by 7. Probability of getting it to be a Tuesday will again be 1 by 7. Probability of getting it to be a Wednesday will be again 1 by 7. Probability of getting it to be a Thursday will be again 1 by 7. And probability of getting it to be a Friday will be again 1 by 7. Or probability of getting it to be a Saturday is again 1 by 7. And probability of getting it to be a Sunday is again 1 by 7. Right? So irrespective of the day, the answer remains the same, that it can be any one day out of these 7. So hence it will be 1 by 7. But what if they ask you find the probability of getting 53 Mondays in a leap year? Now since this was a normal year with 365 days, this is the leap year which has 366 days. Now again, if you divide it over there, you will have 52 over there, 35, 16, 14, the remainder comes out to be 2. Now in this case, there are 2 days. So this can be in a pair of Sunday, Monday, Monday and Tuesday, Tuesday and Wednesday, Wednesday and Thursday, Thursday and Friday, Friday or Saturday, Saturday or Sunday. So these are the possible cases, that these 2 days can be either Sunday, Monday, because they will always be consecutive. You cannot have a Sunday and a Wednesday. So Sunday, Monday, Monday, Tuesday, Tuesday, Wednesday, Wednesday, Thursday, Thursday, Friday, Friday, Saturday or Saturday, Sunday. So in either of the case, you will see one particular day is repetitive by 2 times. So either it is a Monday, the probability will become 2 by 7, or even if it is a Tuesday, the probability will remain same, that is 2 by 7. And if it is a Wednesday, again it will be 2 by 7 and so on. So in such cases, the answer is fixed irrespective of which day they have asked us from this point of question. Right? Then we have some common questions, like if you have 3 red balls, you have 4 yellow balls, and then you have let's say blue balls, right? Let's take them 6. So how many balls will be red? So if we ask you probability of getting a red, this shall be 3 by 13. Probability of getting a yellow ball, this shall be 4 by 13. Probability of getting a blue ball, this shall be 6 by 13. Probability that it is not red, so this will be 10 by 13. Probability that it is not yellow, so that will be 9 by 13. Probability that it is not a blue, so then this will be 7 by 13. So this is how you are going to solve the questions in which balls, marbles, they are fixed, and you are only asked about which particular ball. Now if you ask you probability of getting an orange ball, now since we don't have any orange ball over there, so the probability becomes to be 0. So it is an impossible event. So you can also treat it as example of an impossible event. Now since we have discussed all the possible cases of probability, be it coins or dice or cards, or in which the answer remains the same irrespective of the question, now comes the question which most of the students find tricky. So let's say a bag contains 5 red balls and some blue balls. I don't know the number. If the probability of drawing a blue ball is thrice that of a red ball, find the number of blue balls. Right? So we'll just correct it. This is blue balls. Okay. So now in this case, whenever something is not given, we take it as x. So let the number of blue balls be x. So total number of balls will be x plus 5, because you had 5 red balls, you have x balls which are blue, so the total will be x plus 5. Now he says that probability of red ball is thrice the probability, the probability of a blue ball is thrice the probability of red ball, right? So first of all, we'll write the probabilities. That probability of drawing a blue ball, so since the number of balls which are blue are x, this will be 5 plus x, and probability of drawing a red ball will be 5 upon 5 plus x. Now let us just put these values over here. That probability of a blue ball, that is x upon 5 plus x, is equal to 3 times the probability of red balls. So now let's find it out. This is x upon 5 plus x, which is equal to 15 upon 5 plus x. This got cancels out. X is equal to 15. So you have 15 blue balls. Right. With this, we wrap it up with this particular lecture. I hope you understood it. The main important thing about mathematics is once the concept is clear, you should get onto the practice. And if you have any doubts while practicing, you can always post those doubts in the comment section. And thank you.